Hello students, how are you? First of all, we will discuss some previous chapter question. That is according to the atomic structure. Question number 1 is complete the table show the composition and identity of some atoms and ions. Number 1, as it contains overall net charge 0, so the number of electrons and protons must be equal. Number of protons are equal to the atomic number. What is the atomic number? That is given in there. Atomic number is 5, so proton number is also 5. Net charge is 0, so number of electron will also be 5. Neutron number can be found as using the formula A minus Z, as A is given 10, Z is 5, it means number of neutron must be equal to 5. This was the simple one. Now, second, there is a nitrogen atom. We don't know what the charge is, what the nucleon number, what the atomic number. Periodic table will give us the atomic number of the nitrogen, that is 7. Atomic number 7. And number of neutrons are given as 8. Here we are going to find A. What is A? A can be found by N plus Z, that is equal to A. Nucleon number of neutrons are given here 8 plus 7. 8 plus 7 is equal to 7. 8 plus 7 is equal to 15. That is A. We will use it here, 15. Nucleon number has come 15. Atomic number is 7. Number of proton is also equal to the number of protons, 8, 7. What will be the charge if the number of electrons are 10? Number of protons are 7, number of electrons are 10. It means 3 electrons are more than number of protons, so it will contain minus 3 charge. It means it is a nitrogen ion. What is it? Nitrogen ion. Next, which element in the periodic table has 82 atomic number? It is lead. L-E-A-D, lead. This nucleon number is this. This is atomic number, or same, this is the proton number. What will be the number of neutrons? Neutrons can be found by subtracting proton number from the nucleon number. That is 82. It will become 126. Okay. This is the number of proton in lead, and these are the electron number. So the charge will be a number of electron are less than number of proton. So proton or more, charge will be positive. 2 protons or more, so double charge is present on the lead ion. Next is proton number of neutron is given. So proton number is also the atomic number. 3 plus 3. 3, this is atomic number, this is neutron number. Neutron plus proton gives nucleon number. What is the nucleon number? Nucleon number is 6. This number of electrons would be, as it contains one positive charge, so the number of electrons should be 2. 1 lesser than the number of proton. Then this will have positive charge. What is this ion? This is lithium. Lithium. Lithium ion. Now, same is the question in the second part, which will be solved by your side. Now I am proceeding toward the next question. Question is, beam of proton, neutrons and electrons behave differently in an electric field due to their differing properties. The diagram shows the path of beam of electron in an electric field. Electron is shown as in the electric field. Electron, if electron is deflecting away from this side, it means this side is negative because electron is negatively charged. Negative charge of the plate will repel the negative charge of the electron. So the electron will deflect downward, toward the positive plate. Then what will be the beam of direction of the beam of protons and neutrons here in this electric field? If element, if proton is passed through this electric field, it will deflect toward the positive plate due to the attraction of positive charge toward the negative plate. And in other words, we can say due to the repulsion of proton by the positive plate. Similarly, if neutron is passed, then what will happen? Neutron is remain unaffected from the positive as well as electric charges of the magnetic field or electrical field. This is neutron. Okay. Now we will discuss about our next topic. Let's start our next topic, that is electronic configuration. We will discuss about how the electrons are arranged in the atom surrounding the nucleus. What would be the different electronic configuration mechanism? What would be the evidence of this electronic structure that was given by the Bohr atomic model? We will discuss it through the ionization energy. Then we will discuss about detailed overview of ionization energy. And this, what would be the successive ionization energies? What factors that influence the ionization energies? These all will be discussed in this lesson. First of all, what is electronic configuration? Electronic configuration means arrangement of electrons arrangement of electrons in principal energy level according to Bohr model. Bohr model discuss the arrangement of electron in principal energy levels. Energy levels that are represented by n. If n is equal to 1, then the energy level would be k. If n is equal to 2, then energy level would be L. So on, if n is 3, then it would be M, N, and so on. Bohr atomic model explains that further away the electron from the nucleus, let us discuss the example of calcium. This is calcium nucleus. Its first shell 2 electron. It contains 8 electron in its third shell, second shell, sorry. It contains 8 electron in third. It contains 20 electron. So 2 electron will be in fourth shell. These 2 electrons are much apart from the nucleus than these 2 electrons. So the electrons away from the nucleus will have more energy and less tightly held. These electrons will have high energy and less tightly held by the nucleus. This was the basic idea of the Bohr atomic model, that electrons surrounding the nucleus are in different energy levels. Electrons that are near to the nucleus are more tightly held and have less energy. Electrons that are away from the nucleus are less tightly held and have greater energy. This was the electronic configuration basic idea behind the Bohr atomic model. Then it was further elaborated that every principal energy level is further divided into sub-energy levels, which will be discussed in next lesson and so on. And so, first thing is how we come to know how many electron will be there in our first shell or in our second shell or in third shell. This was given by a formula, that is 2n. If n is equal to 1, then it would be 2 electron. That means first shell will have only 2 electron. If n is replaced by 2, it means square of 2 becomes equal to 4. Sorry. 2n square. The formula is 2 2n square. N is 1, then it will be 2. If n is equal to 2, it means it will be 4. If n is equal to 3, 9 2s are 18. If n is equal to 4, then 32. Put the value of n in this formula and number of electron would come out for any orbit, any principal energy level. It means first shell can up to 2 electron and second shell can have up to 8 electron, third shell can have up to 18 electron, and fourth shell can have up to 32 electrons. This is the electronic configuration of electron in the principal energy level. There are some examples, two of them you will solve, two of them, and two of them will be solved by example number 1 है sulfur 16. It contains 16 electrons. It means nucleus. First shell have 2 electrons. Second shell will have 8 electrons. Then fourth shell just a minute. Second shell will have 8 electrons. How many electrons are left behind? 6. Third shell will have 6 electrons. 6 electrons. It means it have the vacancy of 2 electrons. 2 more electrons can be added to. This is the electronic configuration of principal energy level. Similarly, for magnesium atom, the energy level diagram would be like this. Mg contains 12 proton, so it will have 12 electron in the new orbits. First shell will have 2 electron, second will have 8, and third will also have 2 electron. These two examples you have to solve these two examples. Potassium 19 and fluorine 9. Next question is how we come to know that the atoms have such kind of electronic configuration. To answer this question, ionization energy was used as the evidence for the such kind of electronic configuration. It means, what is ionization energy? First of all, what is ionization energy? Ionization energy is the amount of energy change by firing high speed electrons at atom to form an ion by knocking out one electron from each atom in one mole in its gaseous state. Is called ionization energy, or it is called first ionization energy. energy change by firing high-speed electron at atom to form an ion by knocking out an electron from each atom in 1 mole in its gaseous state. It's called ionization energy. Ionization energy, in other words, can be defined as the amount of energy required to remove the electrons of the outermost shell in the gaseous state of an element. For example, minimum amount of energy required by calcium ion, calcium metal, or calcium atom to become calcium unipositive ion. Calcium positive ion with the loss of one electron. Delta Hi first. First ionization is delta Hi first. Ionization energy is equal to 590 kilojoule per mole. Its second ionization energy would be the successive loss of electron from already formed monopositive ion. This will be converted into dipositive ion and one more electron will be removed. Then the amount of energy required for the loss of second electron will be called as second ionization energy. And second ionization energy would be greater than first ionization energy. Can you think what would be the reason behind this increase in the energy? This is because electrons left behind the calcium monopositive ions are less than the number of protons in the calcium ion. So the positive attraction or the attraction by the nucleus is increased on the remaining electrons. So the second ionization energy would be greater than first ionization energy. With respect to this first ionization energy, second ionization energy would be called as successive ionization energy. Successive ionization energy increases due to charge on the ion as it gets greater by the removal of electron. Let me successive ionization energy. What is successive ionization energy? It is the energy required to remove second or third or fourth and so on electron from the positive ion, already found positive ion. This is an already formed positive ion and we are increasing the charge on it by losing its further electron. So the amount of energy required to remove further electron would be called as successive ionization energy. As each electron is removed, there is a greater attraction force between the proton in the nucleus and the remaining negatively charged electron. So more energy will be needed to overcome these forces. What factors affect the ionization energy? We use the heading factors that influence ionization energies. These are as number one, size of the nuclear charge. Nuclear charge. Generally, ionization energy is directly proportional as the charge of the nucleus increases. Charge of nucleus. Ionization energy is directly proportional to the charge of the nucleus. Let's suppose we are discussing about the second period ionization energy, that is lithium, magnesium, aluminum, sorry, second period is beryllium, carbon, nitrogen, oxygen, fluorine. As the shell remain principal orbital remain 2 and the charge of the nucleus is getting increased 3, 4, 5, 6, 7, 8 and 9. As the nuclear charge is getting greater, so the larger amount of energy would be required to remove the electron from the new outer shell electron. Did you get the point? As the amount of as the charge in the nucleus increases due to the increase in proton number, so the amount of energy, ionization energy required to remove the electron will also increase. Next factor is distance of outer electron from the nucleus. Distance of distance of outer electrons from the nucleus. If the size of the atom due to the number of principal energy level is greater, it means outer electrons are far apart from the nucleus. And we already have discussed the electrons which are apart from the nucleus are less tightly held and have greater energy. So the electrons which are away from the nucleus, it means distance is inversely proportional to ionization energy. If the distance is greater between the nucleus and the outer shell electron, then ionization energy would be smaller. It means least amount of energy would be required to remove the outer shell electron from the atom. Further, the outer shell electron is from the nucleus, lower will be the ionization energy. This was our second factor. Now, what is our third factor? Third is shielding effect. Shielding effect. Shielding effect. Before discussing shielding effect, what we have to define what is shielding effect. Shielding effect actually is the decrease in the electrostatic attraction of the electron and the nucleus due to the inner electrons that are present between the outer shell electron and the nucleus. Let's suppose we say we have an atom which have greater number, which belongs to first, second, third, fourth and fifth period. If we are removing electron here, this electron is being repelled by these electrons. This repulsion decreases the effect of the attraction of the nucleus on this electron. It means, in other words, we can say decrease in the electrostatic attraction. What is shielding effect? Decrease in electrostatic attraction between nucleus and outer shell electrons due to the presence of presence and repulsion of electrons shells between them. These shells, which are residing between the nucleus and the outer electron, are causing the repulsion between them, which decreases the effect of nuclear attraction on this electron. Ionization energy would be lesser if shielding effect is greater. Ionization energy would be small if shielding effect is large. And vice versa. Ionization energy will be larger if shielding effect is smaller. These are the things which we are to discuss today. Now we will discuss in our next lesson about further the electronic structure or electronic rearrangement of the atom. Goodbye. Thank you.